Well, good morning, ASs. We're going to have a look at exercise 9b still, and this is question number 7. So the question starts off with the following. We've got a circle, and they tell us that the circle has a diameter A at the point 5,3, and then also B at the point 4 minus 2. And if we put that there, we also have a point at P, which is on the circumference, called AB. And what we're going to do now is we're going to join P to A, and we'll also join P to B. Now you should know from this that this would make the angle over here a 90-degree angle. Okay, and the reason for that is that we have an angle in a semicircle. They ask us for the relationship between A and B. So that means we need to set up some kind of formula that involves both A and B. Now, the only sensible sort of thing to do here is to consider something like Pythagoras again. Because since we've got a 90-degree triangle, we know that the side PA squared plus the side PB squared must equal the length of AB squared. That's the Pythagorean theorem. So let's set all that up, because that's going to be quite a long sum, but we'll do it anyway. Okay, so first of all, let's see what is the length of AB. Now remember, that'll be the distance between the x points, so that'll be 5 minus A, and all of that has to be squared. So let's start over here, and we'll go 5 minus A all squared, and the distance for the y part, so plus 3 minus b all squared. Alright, and of course the distance would be the square root of that, but since we want the square anyway, because we're going to square PA, we're going to say PA squared, we'll just leave it without the square root sign. Then to do the same for the PB side, that would be b minus 2 all squared. For the y part, and for the x part, a minus 4 all squared. Doesn't matter which side you do it. If you went 4 minus a or 2 minus b, that also is fine, but either way we still got those two sides added together, or those two y and x components, and then we're going to also leave the square root sign out of that because we want that side squared. Now that must equal the distance of BA, okay, all squared. So the distance of BA will be 5 minus 4, which is 1, and 1 squared is just 1. And then 3 minus minus 2, which is 3 plus 2, which is 5. So that will be 25. And of course the square root of that, but again we're not going to square root because we want the square. So answer there is 26. Let me actually rub that out, and we'll write 26. So 26 is the answer. Alright, that leaves us now with the need to multiply everything out here and see what we get. So if we multiply the 5 minus a bracket out, we get 25 and minus 10a and plus a squared. And then we get for the next bracket plus 9 minus 6b plus b squared. And then we get for the next bracket plus b squared minus 4b plus 4. And lastly, we get plus a squared minus 8a and plus 16. All of that is equal to 26. So if we arrange all of that now, we can collect the a squared terms. We've got 2 of them, so we've got 2a squared. Then we again just erase some of the stuff at top here, then we can just use that space as well. Right, so a squared plus a squared is 2a squared. So we'll write that 2a squared. Can you see it over there? I hope that hasn't messed up on the picture, but I think you can just see it, so that should be fine. Also, we've got b squareds, so we'll have 2b squareds And then we've got minus 10a and minus 8a, so that gives me minus 18a. And then we've got minus 6b minus 4b, which is minus 10b. And we can take all of the numbers over to the other side of the 26. So there we've got a 25 plus a 9. 25 plus 9 is 34, plus another 4, which is 38, and plus 16, which is 48, plus 6, which is 54. So if we take that all over to the other side, we'll actually bring the 26 over. So 54 minus the 26 will make it all equal to 0 then, you see. So 54 minus 26 is 28. So we'll put there plus 28, and that all equals 0. Well, since everything can be factorized with a 2 out, we can take it out as saying a squared plus b squared minus 9a minus 5b plus 14 is equal to 0. And that is a satisfactory way of expressing the relationship between a and b. Okay, so there we go. Just by use of Pythagoras, you should be able to see that all that works that way. All right, next question we're going on to. So this is question 8. It says ABCD is a cyclic quad. So if we're going to draw here a circle, all right, that's not the greatest circle. Let's try it again. Right, and then we want to draw a cyclic quad, so let's just draw it in here. And we're just going to make it any old cyclic quad, it doesn't really matter. Let's go here. And then over here. Okay, and the last one over here. So there's a cyclic quad. Alright, it's made a little bit of a mark over here. Let's raise that bit there. Okay, there's a cyclic quad. We'll call it ABCD. Maybe let's put some letters in and we can see what that looks like. So I'm just going to put an A, and let's copy that and make this one B. Go. And then remember, we always keep things going in a clockwise direction if we're labeling. So this one, let's C, and lastly we want D. So there is our cyclic quad. Now what does it say about the cyclic quad? It says that the side CD is produced to E. Okay, so that means that that's this side over here. We're actually going to want to make it longer, so let's do that. And let's put the ruler on the side. And then we'll draw this a little bit further. CD, it says, is produced to E. Right, here we go. And so let's also just add the point E over here. So that point over there is our E. Alright, so CD is produced to E, and outside the circle we want to show that the angle ABC is equal to the angle ADE. So in other words, we're looking at the angle over here. So I'll just draw that in for us quickly. Right, so this angle ABC is equal to ADE, this angle over there. Okay, that's what we're looking for. Alright, so the question is how are we going to do that? Well, I suppose we can already use some of the things we've discovered. So we do know that the opposite sides of a cyclic quad are supplementary. Okay, so let's start by labeling an angle. Okay, I'm actually going to do this. Let's label the angle at B an X. Okay, so just get out of there. Oh, it's gotten stuck again. I don't know why it always gets stuck every now and again. Okay, let's just do it by hand. So X. Alright, that means that this angle over here must be 180 minus X, and this is because we have the opposite angles of a cyclic quad which are equal. Okay, but because this CE is a straight line, it means that this angle over here must be X because it adds up to 180 because it's supplementary, and that means that we've just shown that the angle ADE must be equal to the angle ABC. So it's quite a simple little proof, that one, number 8. Of course, if you had used our previous proof that we did where we worked with the angles at the center and the angles at the circumference, remember we did that to prove the opposite angles of a cyclic quad were equal, you could also just go that route. But since you've already done that proof, it means you know that result. So you're allowed to use that result in this question. Okay, that gives us to question number 9. So let's have a look. Okay, question number 9 says a triangle has its vertices at the point A13. Well, let's draw a triangle to start with. Here we go. It's a fairly decent one. And so we've got a point A13. Let's put those in. So A is the point 1, 3, and we'll put him over there. Then we need B, and B is the point, it says minus 2, 5, so minus 2, 5. So we'll put B over, let's put B over here, it doesn't really matter. And the last one is point C, which we'll need as the point 4 minus 2. So C is point 4 minus 2. Okie dokes, so now we've got our triangle, there it is. Okay, what does it say? It says that find the coordinates of the center and correct to 3 significant figures the radius of the circle around this triangle. Right, so we don't know really what kind of triangle this is. It could have been equilateral, could have been isosceles, it could be just a scalene. Okay, it doesn't really matter. But what we do know is that we're drawing a circle around this triangle. So let's maybe try and do that as well. Let's go and see if I can get a nice circle around the triangle. Alright, so that's not too bad as a circle. We can maybe move it. Let's see if we can just shift it up a little bit. There we go. Right, that's pretty much around there. So there we got a triangle inside a circle. And they want us to find the center of this circle. Okay. Now, to find the center of the triangle, we can do that by drawing a series of medians. Okay, and remember, a median is a line that goes from one point of the triangle and cuts the other side in half. It's not necessarily at 90 degrees, it just cuts it in half. I know this one looks like it's 90 degrees, but that's not necessarily true. Okay, and we could do these medians from every corner of the triangle. to its opposite side. Okay, and we'll also do it over here. And if we've drawn it nicely, there we go. These lines will all cross at the center of the triangle, which will also happen to be the center of the circle. Okay, because we've got lines that are crossing from the one side of the circle to the other if we've extended them, and they all meet at a certain point, so that will be the center of the circle as well. So the question is, what is the equation of those lines, or any of the two lines? Okay, so the first thing we're going to do is go and say, well, what's the midpoint of, let's choose AC. So midpoint, remember, is the sum of the x plus the sum of the y, and each one over 2. So the midpoint of AC, let's have a look there. So MP of AC. Well, that must equal the 4 plus the 1, which is 5, so that's 5 over 2 if we halve it. And also the 3 and the minus 2, which is 1 over 2. So there's our midpoint, okay? Then I'm going to find the equation of the line which goes to that midpoint from B, okay? So we're going to use this midpoint point, and we're going to use the point B, which is minus 2, 5. So the first thing I'm going to want there is the gradient, okay? So the gradient of that line will be change in y over change in x, which is 5 minus a half. Okay, 5 minus a half is 4.5, or 9 over 2. And the other one is minus 2 minus the 2.5, which is minus 4.5. Well, that actually makes a nice answer. We didn't have to do too much working out. We get minus 1. So that's the gradient of the line that goes from here to B. Okay, or that line that I drew over there. So that's the gradient of minus 1. Let's then put in the point minus 2, 5, and we'll get y is equal to minus 1x plus c, and therefore the 5 is equal to minus 1 times minus 2, which is 2 plus c. That makes our c equal to 3, giving us an equation for that line of y equals minus x plus 3. Okay, that's a nice easy equation, and we're going to keep that one. We're going to need another equation, so let's work out the line that we drew over here. Can you see? Okay, that line's equation. So again, we're going to need the midpoint now of AB. All right, I'm going to erase all the other stuff that we had here. We just want to keep that equation, which is the y equals minus x plus 3. So for this one's midpoint, the midpoint is going to be minus 2 plus 1, which is minus 1. So that's minus a half. Okay, so we've got a minus a half for the midpoint. And then from the B to the A, 5 plus 3, which is 8, so 4. All right, so there's my midpoint. Now I want to work the point from that midpoint to C, or the line that we want there. So we're going to need the gradient. Okay, so the gradient here is 4 minus minus 2, which is 6. That's a change in y. And then for the x, it's minus a half minus 4, which is minus 4.5, or minus 9 over 2. All right, that makes the gradient a little trickier. Just remember, if I divide by a fraction, I invert and multiply. So that's the same as multiplying by 2 over 9, which would be 12 over 9. So that will be minus 4 over 3. Are you all happy with that? There's my gradient of that line. So minus 4 over 3 is the gradient. Let's put in the point, which is 4, 2. And so again, we're going to start with y is equal to, I'm just going to put the gradient in, minus 4 over 3x plus c. And we put in the point 2 is equal to minus 4 over 3 times 4 is minus 16 over 3 plus c. So if I take that over, I'm going to get 6 over 3 plus 16 over 3, which is 22 over 3. There's my c. All right, and so I can rewrite this equation as y is equal to minus 4 over 3x plus 22 over 3. Okay, let's erase a few things again here. Y equals minus 4 over 3x plus 22 over 3. All right. So that gives me two equations. Now we want to find where these two equations cut each other, because that's where that center is. Okay, so let's make that then equal to each other. Okay, that's the most sensible thing to do if we want to find where a point cuts. we just make them equal, the equations of the lines. Alright, I'm actually going to rewrite that equation as the minus 4 over 3x plus 22 over 3 as 3y equals minus 4x plus 22. Okay, so let's write that over here. 3y equals minus 4x plus 22. That was just multiplying the 3 away. Okay, so far that's not too difficult. Now let's multiply the bottom one also by 3. Okay, and that also gives us 3y, but that gives us minus 3x plus 9. So 3y minus 3x plus, and we'll change that to a 9. Okay, that means we can eliminate the y by subtracting. So 3y minus 3y is 0. But what's minus 4x minus 3x? That's minus 4x plus 3x, which is minus x. Okay, so now we have 0 equals minus x. And 22 minus 9, that's not too difficult. It is 13. Okay? And that simply means that the x value is 13. Alright, to go and then solve the rest of the equation, we'll put that x value in. So let's put in 3y is equal to minus 4 times 13. That's minus 52 plus 22. Okay, which gives me minus 30. So if 3y equals 30, it again means y equals positive 10. So there we go. We've got an x and a y point. 13, 10. Alright, so that is the center of the circle. 13 and 10. Okay, so that gives us a little bit of an answer for the first section. They did say correct to 3 significant figures, but I think we've got an answer that's actually quite comfortable. I'll check it now. And then they said, oh sorry, the radius must be the 3 significant figures. Alright, so let's have a look at now what the radius is. So let's write an equation for the circle. Okay, we know that the center is 13, 10. Maybe I'm going to type that in for us quickly, then we can just have it there. Let's put here, sorry. So let's put it O and 13, 10, and that's that point over there that we were interested in. Okay, we'll also erase everything else. Now we can use our formula for writing the equation of a circle, and that should give us let me see if I can get rid of these circles quickly. There we go. Right. So with a center of 13, 10, what would be the equation of the circle? Well, that must be x minus 13 all squared plus y minus 10 all squared must equal r squared. Okay, now we don't know what r is in this case, okay, but we do know that the formula must look like that. Okay, so we've got to go and work out what r is. Well, the thing is, we'll need points on the circle. Okay, so we can substitute any of either a, b, or c because all of those points are also on the circle. So let's use a, which is 1 and 3. Okay, so that means that 1 minus 13 all squared plus 3 minus 10 all squared is equal to, and it is r squared. Okay, well, 1 minus 13 we know is minus 12, so this is 144. And 3 minus 10 is minus 7, and that's 49. So we end up with 189. And what is the square root of 189? I actually think that's 17, if I'm not mistaken. So, yeah. So I don't know why they wanted 3 significant figures if the question worked out so very nicely. I'll check the back of the book quickly. Sorry, I'm lying. 17 is 289. I got a bit confused. So, alright, we can work out the square root of 189. What is the square root of 189? I'm sure you can work that out on your calculator. I just don't have my scientific calculator with me at the moment, but that'll give you an answer to 3 significant figures, and that's what they wanted. So there we go, you've got question number 9.